All right, good morning, mathematicians, or good afternoon, mathematicians. Some of you will be in the morning, some of you will be in the afternoon. That's beside the point. All right, so today we're going to take a look at lesson 2.3, unit rate and constant of proportionality. Okay, our focus question is, how can you find the unit rate in a description, equation, table, or graph? So we're actually going to have some exposure to each of these types of situations. Okay, but first let's try and get some definitions going here. For the constant of proportionality, I honestly feel like this was probably the most difficult definition to get in your vocabulary, and really the easiest way that I can think of to explain this is this. In an equation, right? We're going to be dealing with equations today. In an equation, the constant of proportionality is the number that we multiply by the variable. Okay. In the previous investigation, right, we were talking about pizza prices. We came up with two equations that look something like this: P equals 12 times n. What would be the constant of proportionality here? What number are we multiplying by the variable? Well, the way I read this, P equals 12 times n, right? 12 is the number that we're multiplying by the variable. So 12 is our constant of proportionality. Eventually, we're gonna think of another word that describes the constant of proportionality. Something that'll become it'll become second nature, but it's going to be a little bit easier to understand rather than this very long vocabulary word. Okay. All right, let's talk about some unit rates. Unit rates. I found this definition that I really liked. It was how much of something per one something else. I know this sounds a little strange, but we'll explain it in a second. So how much of something per one something else? Let's write that down. For unit rate is how much of something per one something else. And I really want to put the emphasis on the number 1. Okay? So 1 is always going to be part of unit rate. So how much of something per one something else? Well, you're probably saying, Mr. RG, that still doesn't make any sense to me. Well, let's think of a few examples. So if we can write some examples over here on the left column. Examples of unit rates. So going back to the previous investigation, we said one good example was $12 for how many pizzas? 1 pizza. Okay, so here's our 1. The 1 is super important. Let's think of another one. What about this? 25 miles per 1 hour. You guys probably read this as just 25 miles per hour. The 1 we kind of skip, right? But it's still there. 25 miles per 1 hour. If we're talking about sports, you could say 6 touchdowns per 1 quarter. That'd be good. 6 touchdowns per 1 quarter. Our 1 is right there. Okay. These are all examples of unit rates. Okay. This 1 is super important. I will say it however many times you need me to say it, but that is what a unit rate is. So with that, let's take a look at this problem here. We are on question A. It says fresh Foods, I almost said Fresh Fruits. Fresh Foods has oranges on sale at 10 for $2. So 10 oranges for $2. I'm going to write that down underneath here. 10 oranges for $2. For each part, find the unit rate. Be sure to label your answers with the proper units. So this first question here is asking us, what is the per orange? Please add the word price here. What is the price per orange? Well, some of you may already know how to do this, but for those of us who may not know what to do, let's go ahead and create a proportion here. So I want to find the price per 1 orange. So if I write my proportion, I should have 1 orange on top and X dollars on the bottom. Now I have something to solve for. Now I can solve this proportion. Well, one way I can go about doing this is, how can I go from 2 to 10? Well, let's multiply that side by 5. Right? So if I multiply 2 times 5 to get 10, to move backwards, right? Pause. I should be able to multiply x by 5 to get 1. So how do I solve for x? Well, now would be a great time to pause the video and try and solve this on your own. So hopefully you paused the video and you've tried this. So to move backwards, to solve for x, we're just going to take 1 and we're going to divide it by 5. Type that into your calculator and you get 0.2. So your first inclination is probably to say x equals 0.2, but 0.2 what? We need to be specific. We need to make sure that we label our answers with the proper units. So 0.2, what were we solving for? We were solving for the price. So we need to make sure that we include the price. So x equals 20 cents. Let's keep going. How many oranges can you buy for $1? So I'm going to start this again by writing a proportion. So I know that 10 oranges are $2. And you guys, this is just to get you started if you're stuck. Okay? We want to know how many oranges, so we don't know how many oranges you can get for $1. All right, now I encourage you to pause the video here and try and solve how many oranges can you buy for $1. All right, hopefully you paused. Let's see how we solve this. Well, I can go 1 to 2, I multiply that by 2, so I should be able to multiply this x by 2. Right, so what number times 2 gives me 10? Well, 10 divided by 2 is 5. So it looks like x is equal to 5 oranges. And that is my answer. Really quick, before we move on to this table, I would like us to write the 2 unit rates that we have at the bottom here. So the 2 unit rates that we covered. The first one. What is the price per orange? We said that the price per orange was, well, that's 20 cents per 1 orange. Right, and there is my 1. I'm sure you guys can think of the second one. The second one is 5 oranges for $1. And there's my 1 again. Okay, so again, unit rates all revolve around the number 1. That is super important. Okay, now I encourage you to pause the video. Try and fill in the blank spaces on this table. Okay, so hopefully you paused and are now ready to fill in the numbers on this table. Let's fill in some easy ones. Well, we figured out how many oranges we could we could buy with $1. And that was 5, right? That was one of our unit rates. Just go ahead and fill that in there. And then how much does one orange cost? Well, that costs 20 cents. So there we go. Those are our 2 unit rates there. What about for 20? 20 oranges. How do I solve this? Well, if you notice that I have 10 right here, right? 10 oranges cost 2. Well, can I just double that? Yes, you may. So what's $2 times 2? Well, that's going to be $4. All right, let's try 11. 11 oranges costs how much? Well, if 10 oranges costs $2 and each orange costs 20 cents, it would make sense to add 20 cents to $2. So let's add $2.20. Okay, the last one. We need to figure out how many oranges cost $2.60. I'm going to work over here. So we know that 10 oranges cost $2. Oops, that is not $2, that is 20. There we go, $2. And we know 1 orange costs 20 cents. How many more oranges do I need to add here? Right? Hopefully you'll notice that at 11 we're at 220. Let's add another 20 cents, which is $2.40. This is 12 oranges. Let's add another 20 cents. And now we are finally at $2.60, which is the cost that we are trying to figure out, and we are at 13 oranges. Okay. And there we go, our table is complete. Let's keep going. How does finding the unit rate help you answer the questions such as the ones below? Take a moment and think about this. How did we use the unit rate to help us solve these types of problems? What did we do in question number 3? How did we find the costs for 20 oranges, or find how many oranges cost $2.60? Okay, think about it. Talk with your neighbors, please. All right, so one way that sticks out to me is how does finding the unit rate? Well, having the unit rate helps us write proportions. Helps us write proportions, right? But I mean, technically, any ratio will help us write a proportion. So what specifically about the unit rate helps us? Well, if we take a look here, the first bullet says how many oranges can you buy for $5? Right? If we take a look at this unit rate here, all right, if there are 5 oranges for $1 and we're spending $5, what can we do? Hopefully you said multiply 5 times 5, right? If 5 oranges cost $1, $5 must be 5 times 5. So where am I going to write that? Hold on, give me 1 second. So if 5 oranges cost $1, you multiply the number of oranges by 5. Similarly, if I'm trying to figure out how much do 25 oranges cost, right? How can I use this unit rate? Well, 25 divided by 5 equals 5. So using the unit rate this way really helps us. It kind of makes things go a little quicker, okay? All right. Let's talk about question number 5. Question number 5 is a little strange for us, but we're going to talk about this. So first, whenever we look at an equation, we want to figure out what does each part of the equation mean. So in the left column over here, let's write our equation. So n equals 5 times c. Well, what does the letter n represent? Hopefully you said n represents the number of oranges. Okay. What does c represent? Well, c, hopefully you said, is your total cost. And lastly, what does 5 represent? Where did this 5 come from? Well, take a look back at our unit rate here, our second unit rate, 5 oranges for $1. So this represents 5 oranges for $1. So, going back to this question, what does this equation tell you about the relationship between the number of oranges and the cost of oranges? Well, if we say that the number, let's just read this out loud using the words that we created here. The number of oranges, starting with n, the number of oranges, so let's write that down, the number of oranges is equal to 5 times the total cost. Boom, it's that simple. Number of oranges is equal to 5 times the total cost. So if I give you a total cost, you multiply it by 5, you should be able to tell me the number of oranges. Let's take a look at question number 2. Question number 2 might be a little tricky. What is another equation relating these same two variables? What information does this other equation give you? I want you to take time to think about it on your own. Think about how else can you write this equation? What other equation can you write that relates the number of oranges to the total cost? Okay, so what is another equation relating these same two variables? Well, we started with n equals 5 times c. I want to write an equation. That that says something like this: c equals. What would c equal here? I read this equation, the one I underlined, as 5 times a number c. 5 times a number is equal to n. Right? So I need to multiply some number by 5 in order to get n. Well, how do I get c then? How do I figure out what value c is? Right? This might be a little confusing right now. So let's plug in some numbers. What if I wrote this? What if I said 40 is equal to 5 times 8? Okay, so we definitely know that 5 times 8 is equal to 40. How can I use these three numbers? How can I rewrite this to solve for 8? Well, if you do 40 divided by 5, you definitely get 8. We're going to apply the same logic here, but now we're just going to apply it to our equation. So if we think of this as if n is 40, if 5 stays the same, and c is 8, right, and we have a multiplication symbol there, let's rearrange this so that we have c we said that 8 is equal to 40 divided by 5. But let's go ahead and fill this in with the green. Let's go ahead and fill in these values. We said n was where 40 is, and then we need to divide that by 5. So it looks like our new equation is c equals n divided by 5. Okay, I'm going to erase these purple numbers just because I need to write a little bit more. Okay. So we have c is equal to n divided by 5. Well, let's put that into words. What information does it give me? Well, we said up here, we said c is the total cost. So let's start with that. The total cost, and then we have an equal sign, is equal to what? N stood for the number of oranges. Divided by 5. Okay, so that's what this equation gives us. Next, it says to identify 2 unit rates from these equations. Explain how you found the unit rates. What information do the unit rates give you? Okay, so let's write our 2 equations next to each other. So we had n equals 5 times c. And then we also had, I'm going to switch to purple over here. Then we also had c is equal to n divided by 5. How in the world are we going to find some unit rates here? Well, what did this 5 represent again? Take a look back up on the page. We said that this 5 was 5 oranges for $1. Okay, so that's our first unit rate. How are we going to get the second unit rate from c equals n divided by 5? First, let's write the other unit rate that we need. The other unit rate was 20 cents per 1 orange. We're gonna mess around with this second equation here. So you guys should be okay with me rewriting this as c equals n over 5. Right? I still read this, even though it's in a fraction form now, I still read it as n divided by 5. Okay? Now let's see, what can I do? With this equation, I'm going to say I know what we should do. How can I rewrite n divided by 5, but I want to write it as a multiplication problem, right? And this is going back to scale factors and all of that good stuff. How do I rewrite n divided by 5 as a multiplication problem? If you remember correctly, we can just multiply by 1/5. Multiplying by 1/5 is the same exact thing as dividing by 5. So now we have an equation that looks something like this. We have 1/5 n. But does 1/5 match with our 20 cents per orange? Well, let's talk about that for a second. Let's talk about that. Is 1/5, I'm going to be working over here in the column, is 1/5 the same as 0.20, as 0.20, or 20 hundredths? Oh no, my battery's dying. Okay, I gotta finish this quickly. So pause the video for a second. Are these two things the same? Go ahead and work. All right, so hopefully pause the video. Let's change 20 hundredths into a fraction. Right, if I divide both of the, if I divide the numerator and the denominator by 20, do I get 1/5? Yes, indeed. So my final equation that I'm going to write is C equals 0.2, right, 0.2 times n. So this is a decimal, this is a multiplication symbol. So this equation is, this gives our unit rate of 20 cents per 1 orange. Woo, that was tough. Okay. Last question on this page. How does the constant of proportionality relate to the unit rate? Remind ourselves, what is the definition of the constant of proportionality? Take a look back at the vocabulary. Remember, in an equation, the constant of proportionality is the number we are multiplying by the variable. So in both of these cases, in n equals 5c and c equals 0.2n, aren't those our unit rates? So can we say that the constant of proportionality is the unit rate? Why, yes, we can. So let's write the constant of proportionality oops, I'm going to cross out some of my work here. The constant of proportionality is the same as the unit rate. Woo! Excellent. Okay. So go ahead and take a second to write that down. Go ahead and pause it if you need to, but we're going to keep going. So question number 5 asks us to graph the two equations. We're only going to graph one of them. So we're not going to graph n equals 5c. Instead, we are going to graph c is equal to 0.2n. Okay, so along the x-axis here, along the bottom axis, is the number of oranges. And then along the side here is the total cost. And this is in dollars. Oops, that is not a dollar sign. This is in dollars. Okay, so it might help to make a little table here. Oops. My variables are n and c. Okay. Let's try. We know that for 5 oranges, right? So 0.2 times 5, that's going to be 1. Let's stick with some simple numbers here, because decimals are not fun to graph. So let's go ahead and let's do multiples of 5. Let's do, if we have 10 oranges, so 10 times 0.2 is going to be 2. Let's do 15 times 0.2, and that's 3. I think we're getting somewhere. And then let's do 20 times 0.2, and that's 4. Okay, let's go ahead and start graphing this. So find 5 along the x-axis, that's right there, and go up to 1. Find 10 along the x-axis, and that goes up to 2. Find 15, and so on and so forth. That goes up to 3. And then 20 is at 4. Oh, let's include 0 in this as well. What happens when we have 0 oranges? Hopefully you're paying $0. And that's going to be right there. Go ahead and connect your line, please, or connect your dots, excuse me. Boom, there we go. So your graph should look something like this. Excellent. Let's keep moving on. how can you use these graphs to find the unit rate? How can we use these graphs to find the unit rate? How can you use these graphs to find the constant of proportionality? Well, it's going to be awfully hard to find the unit rate, right? The unit rate, remember, for this graph here, the unit rate is 20 cents per 1 orange. So to find the unit rate on the graph, everybody, all you're going to do is you're going to look at the x value 1 and find it on the graph. See, and that's going to be right there. So this coordinate right here is going to be 1 comma 0.20, and that's going to be our unit rate from the graph. So when in doubt, to find the unit rate from the graph, find 1 on the x-axis and follow the 1 until you reach the line. Okay, and then you're going to write your coordinate. And then this right here is, of course, our unit rate. So let's write that in words, please. Let's write down what we just said. Find 1 on the x-axis. Then we go straight up, move straight up. Until we hit the graph. The y-coordinate is our unit rate. Remember, so for number 7, it says, how can you use these graphs to find the constant of proportionality? Remember, the constant of proportionality, I'm going to start calling it CP. It was the same thing as the unit rate, right? These two things were equal. So why don't we just use the same logic? So we can say same as above. Okay, so let's take a look. How much more do we have? We have B and C. Okay. All right, we just need to get through questions 1, questions 2, 3, and 4. That's all we're going to be able to cover today. So, yeah, so 3 and 4. And then we will finish the rest up later, okay? So let's talk about it. So I'll start you off, and then you guys can pause the video and work on these 4 problems, and then you guys will come back and review your answers, okay? But I'll start you off. So Noli's car uses 20 gallons of gasoline to 600 miles. Our first question asks us to write 2 unit rates relating the number of miles Norley drives and the number of gallons your car uses. So we need 2 unit rates. We need gallons, the number of gallons per 1 mile. So that's our first one. And then I'll do the second one in blue. Then we need the number of miles per 1 gallon. Okay. So let's go ahead and get to work. You are finding these 2 unit rates, gallons per 1 mile, miles per 1 gallon. So go ahead and pause the video and get to work. All right, hopefully you pause the video. Let's go ahead and solve these. So let's solve for the first unit rate. We want to find the number of gallons per 1 mile. So let's write some proportions, you guys. Proportions always work. So 600 miles to 20 gallons of gasoline. I want to know how many gallons, so it looks like we're going to have X gallons here, for 1 mile. And we're good to go. Okay, so how do we solve this? Well, how do I go from 20 to 600? I can multiply that by 30. So therefore I need to multiply x by 30 to get 1. So I solve this by doing 1 divided by 30, and you're going to get 0.03 repeating. What does this number mean? 0.03 repeating, what does that mean? Well, what were we solving for? We were solving for the number of gallons for 1 mile. So when we travel 1 mile, we go 0.03 repeating gallons per 1 mile. Okay, so we found our first unit rate. Let's find the second one. So again, we can set up a proportion here. So 600 miles. Right, I'm using this because this is the information they gave us, right? This ratio right here. So use it to your advantage. So now I am looking for how many miles per 1 gallon. So how far will I go with only 1 gallon of gas? So now x is in the numerator here. And we're going to do something very similar. How do I go from 20 to 600? Well, I still multiply that by 30. And this time, I can multiply 1 by 30 to get the amount of miles. So if I do 1 times 30, that equals 30. Don't forget to tell me what units we're in. So this is 30 miles per 1 gallon. And there we go. We have our 2 unit rates. Let's keep going. It says the graph below shows the relationship between distance d and gallons g of gasoline. Which unit rate appears on the graph? And explain how you know. So remember, to find unit rate on the graph, the unit rate on the graph is on the coordinate 1, comma, and I'm going to put a y here just because it could be any number. So let's go ahead and find this coordinate. I'm going to highlight it. So, what is happening? Oh no, my pen died. Okay, so I'm going to have to write with my finger. We'll see how this goes, you guys. So find 1 on the... No! Okay, I'm sorry guys, my my stylus died. So now my here, let's see if this works. Oh, there we go. Okay, now I can use my fingers. So there's 1. Let's follow it all the way up the graph. Boom, there we go. What is that coordinate? That coordinate is 1, 30. Which unit rate is this? Well, it looks like that's the 30 miles. I'm sorry guys, this is pretty 30 miles per 1 gallon. Okay. All right, I'm sorry you guys. I can't keep writing like this. So what I would like you to do is I want you to answer questions 3 and 4.